Hello, my name is Tobias Leimbach and I'm talking today in this video about an assignment within the course Machine Learning for Project Managers from Duke University at Coursera. The assignment is to develop a model to predict the electrical energy output of a combined cycle power plant. A combined cycle power plant is a power plant that generates electricity by combining a gas and a steam turbine system. Air is compressed and mixed with fuel, usually natural gas. The mixture is burned, producing hot, high-pressure gas. The gas expands, driving a gas turbine connected with a generator producing electricity. The hot exhaust gas from the gas turbine are directed to the heat recovery steam generator. In the HRSG, the exhaust gas is used to generate steam. The high-pressure steam drives a steam turbine connected to another generator, producing more electricity. The steam is then condensed back into water and recycled. The key advantages are increased efficiency, fuel flexibility. So the course project, we received a set of nearly 9,600 hourly average ambient environmental readings from a sensor at the power plant. The values are temperature T in the range of 1.81 to 37 degrees Celsius, the ambient pressure, the relative humidity RH, the exhaust vacuum V, and the net hourly electrical energy output PE, which is the target that we are trying to predict. As a selection of working method, there are three models. First is using Excel, second using Python, third using Google AutoML. In this assignment here, I selected number 3, using Google AutoML. So each of the below steps I have to run in the modeling process. All steps have to be completed. The first one is to determine what type of machine learning approach is needed and selected as an appropriate output metric to evaluate performance in accomplishing the task. The second one is to determine which possible features shall be used in the model and identify the different algorithms. The third one is to split the data into a test set to evaluate the performance of the final model, and a training set to determine a validation strategy for comparing different models. A fixed validation or cross-validation can be used. Then the validation approach is to compare the two models, which can be either a different algorithm, the same algorithm with different combinations of features, same algorithm and features with different values for hyperparameters. Then the model with the best performance shall be used for validation of the final model. The fifth step is evaluate the performance of the final model using the output metric which has been defined earlier. So which model has been selected? I decided for a supervised learning because it's a prediction of a target variable, and I used as learning task a regression algorithm. So I uploaded the CSV file, the given CSV file into Google AutoML. So here it's visible, the 9,600 parameters. Here it shows the parameter within the CSV files AP, AT, RH, and V. And the output, the target that we are trying to predict is PE. The model has then been trained. I'm using now two optimization algorithms. For the upper one, I'm using MAE, mean absolute error, and the lower one, I'm using RMSE, root mean square error. I'm using these two because they are more robust to outliers. Then for splitting the data, it's quite easy with Google AutoML because here you can just enter the data split. I'm using for training 80% of the available parameters, for validation 10%, and for testing also 10% as test set. For the results, I have here the results displayed for RMSE, both on the upper part, and MAE, both on the lower part. The training time is approximately 2 hours each. So it took me 2 hours to run each of the models. So I used now several combination with here with all input variables, and here I reduce the least feature importance, which is RH. So here for this model I have only 3 parameters. So as I already explained, here I'm using the same algorithm with different combination of features. And now I'm going on with the best performing model. The best performing model in this case has now a R square 0.967, which is a quite good result. And now I'm using this model to evaluate the performance of the final model. I'm using now here the Google AutoML to test the model. It tells me 95% of the parameters are, all the predictions are within 95% of the prediction interval. It tells me the prediction result of these parameters here. And now I'm running the complete batch of parameters. So it shows me all predictions are within the correct range, which is here 0. It's -3 until +5%. Here I have also some outliers, but only in the positive area. And I did also some statistics, which are now showing here. The statistics, how much it deviates from the correct value, and it tells me about when 68% of all the parameters are within this range, 95 and 99.7 are within a range of -1.5 to +164. Which is a quite good result for it.